All right, today we're going to take a look at piecewise functions and how to graph these things, how to evaluate them at different domain values. And I remember teaching this in Algebra 2, and sometimes students had some troubles in this. I'm currently working with my pre-cal students reviewing this, so I thought I'd make this video to help them out and hopefully help you out. All right, so let's get right to it. So piecewise functions are where you have different, let's just call it pieces for now, so different pieces that are conditional or based on the domain, which is, of course, inputs, and it's x x's. So depending on what x is going in, we look at different pieces. So we evaluate piecewise functions by looking at the x value and determining which piece to use. I'm going quickly as I can, so I apologize for the horrible handwriting. So you're going to look at that x value and then you're going to figure out which piece to use. This will make more sense here in a moment. So graphing piecewise functions, you're going to split the graph into regions, and then you're going to graph the different pieces only in the correct region. All right, so let's scroll down here. We're going to do two different examples. This first one is, let's do this one first here. So we have two different pieces. We have two different pieces in this. And do you notice that the first piece is a line, right? It's the line y equals x. So I'm going to write that down, y equals x. And then the second one, I'm going to use a different color. It is a parabola because it's an x squared graph, and it is y equals x squared. Now, there is a transition from one to another that happens at x equals 0. So when we are on the region of the graph, this would be quadrants 2 and 3, where x is less than 0. So over here, we're going to be on the line. We're going to have the line graphing. And then when x is positive or equal to 0, which is over here, we're going to be drawing the parabola. All right, so let's do this. Let's draw a dotted line at the boundary first of all. I'm trying to pick a different color here. So we have the boundary here. I don't know if you can see that on the screen here. The green here, that's our boundary line, x equals 0. So that came from this right here. Now, on the left side, I'm going to shade it red because this is where we're going to have to draw the line portion. Okay, so if we're going to draw the line, y equals 1x plus 0, right? This has an mx plus b form. It's, of course, the identity function here. It starts here and it goes up like this. But that's not in the red region, is it? So I'm going to erase those dots. And I'm also going to erase that one. And I got to draw the line that goes down like this, down and to the left. That's y equals x. So it goes like this. All right, now I'm not going to worry about open circle, closed circle yet. You might know what I'm talking about, but just hang tight here. Let's see what happens with this parabola. So on the right side is my blue part. That's my parabola. So over here, I'm going to draw the parabola. Notice how that red abruptly stopped. So the parabola has a vertex at 0, 0, and then it goes like this normally, right? 1, 1, 2, 4, 3, 9. That's what a parabola looks like. However, again, I'm not going to graph these dots over here. I'm only going to graph the stuff over here. So let me get rid of those dots and start over here. And my dots go like this. 1, 1, 2, 4, 3, 9, and then I'm off my grid. So here is the portion that is a parabola. This doesn't always happen, but this thing does connect here. So I'm not going to put any sort of dot there. I'm just going to leave it like that. So when x was less than 0, we were on the red line. But the moment we hit x equals 0, we're on a different piece. That's why it's called the piecewise function. And that other piece is over here. All right, we have some questions down below. We can now read it off the graph or think about it with the function. What is the value of f of 2? So since x equals 2 is greater than or equal to 0, right? X is greater than or equal to 0. I'm using blue because we're on the blue function. So f of 2 is going to be 4. Y equals 4. So if you come up here, x equals 2 is greater than 0. So that's why I would do 2 squared is 4. So if I didn't have the graph, I would go up here and look at the conditionals. That x is greater than or equal to 0. So we're putting 2 in, so I'm going to use the blue part of it. All right, let's see what else it has. F of 0, well, that's easy. That's actually right in the middle. That's going to be 0, and you can see that 0 is greater than or equal to 0. So once again, 0 squared is 0. So this would be 0. All right, let's go on to the next graph. This one's a little trickier. We have a reciprocal function. So I'm going to draw these two over here because I did this in class when I did notes the other day, and I thought it was really helpful for the students to see this. So this is going to be y equals 1 over x. So here's 1 over x, looks like this. Okay, and it actually hits at 1, 1, and then this would be -1, -1. All right, so that's important to note. That's 1 over x. Now off to the right there, I'm going to graph the y equals the absolute value of x portion. That is a line that goes up like this in one direction, but then it's actually got a negative slope in the other direction. So it's a V-shaped graph, and once again, it hits at 1, 1, and then this would be -1, 1. Okay, deep breath here. Here we go. So let me zoom out. Where is our boundary this time? Where am I going to draw that green dotted line? I'm going to draw it on -1 this time. So it goes like this. All right. Now, on one side, I'll do my red highlighting. So when x is greater than or equal to 1, or -1, sorry, I'm going to be using the 1 over x function. And then, when it is less than -1, I'm going to be doing the absolute value of x function. These colors make this a lot more helpful, in my opinion, easier to understand, hopefully, and teach. So let's go back to the red. I have to draw my green dotted lines on these functions up here because this is where the transition happens, right? So for the red graph, I'm going to be doing this. For the blue half, I'm going to be drawing this. That sort of makes sense? It's a little confusing, I know. So here we go. We know that this 1 over x, the reciprocal function, looks like that over there. I said it goes through 1, -1, or 1, 1. But I also said it goes through this dot right here. So there's a portion of it over here that we need to draw. And but to the left of, so to the left of, I do this on the camera for you, to the left of x equals -1, we need to draw the blue graph. The blue graph is going to be an absolute value function that looks like this. But I don't draw it all, right? I start it right here, and this is all I'm drawing of it, is up and to the left, or down and to the right, but it abruptly is going to stop right here. Now we need to decide open circles or closed circles. So let me get rid of this green for a second. Open circles or closed circles. So a lot of students ask me about this. Because this is lacking the equal sign, it's an open circle. Because this has an equal sign, part of it, when x is -1, we're going to be using this function. So that's where the closed circle would go. All right, so let me grab my colors. We got red is going to be our closed circle. I'm going to really exaggerate it. And then the blue one is going to be the open circle. Right? And it was because it does not have the equal part, folks. There's the graph. A really wild and crazy graph. So let's use the graph here, or actually, when f of -1, where are we at? Well, we go to -1 and we say, where are we at? Are we up here or are we down here? Well, the closed circle's down there, so that's where we're at. That's at -1, -1. So this would also be -1. What is the value of f of 3? This would be over here. We can't really read that one off the graph, but we can go back to the function. It would be 1/3 equals 1/3. All right, so that's graphing a couple of piecewise functions. All right, let's do one more here. This one has 3 pieces, and we'll try to go a little more quickly for you, okay? The middle piece is actually really easy. Do you notice that this is just when x equals 0? When x equals 0, we have a closed circle. So I'll use black for that one. This will be my black one, okay? So I'm going to put a big, fat, closed circle right there. When x is 0, y is 5. So that's just a dot. So this is just a dot. Now the other ones, I have to graph y equals x minus 2 on this side over here. No, I'm sorry, I got it wrong, don't I? On this side over here when x is less than 0. All right, so I go down 2, I put a dot there, and then I go, the slope is up 1 over 1, but remember I need to go the other way, so I'm going to go down and to the left and draw my arrow that way, like that. I put an open circle there because it does not have an equal sign. The equal sign is right here. We've already put a closed dot there. Now, let's graph the other line. Let's do that one in blue. This will be y equals -2x plus 3. You see how I just rearranged it? The mx plus b graphing makes it a little bit easier, right? So we're going to go down 2 over 1, but we have to go up 3 first. Then we go down 2. Always go to the right if you want to be right, like I said in my y equals mx plus b video. And we go here. Now I do need to fix something. What do I need to fix? I shouldn't have a closed circle. I got a little excited and I drew a circle right there. That is supposed to be a big open circle there. That is supposed to be an open circle. Look how crazy this graph is. By the way, does this pass the vertical line test? Over here, yep, only hits once. Over here, yep, only hits once. And right here in the middle, it only hits once. It hits up here because the others are open circles. All right, what is the domain of this thing? It exists everywhere left to right. There are no jumps in the domain. So the domain here would be -infinity to infinity. What is the range? Range is where you turn your head to the left and you say, how low does it go? Well, it starts at -infinity. It exists here. It exists here. It exists here. It exists all the way up to, what is that, 3. But we have to leave 3 out because this is an open circle. We then jump to 5, and really it's just only 5, right? So I'm going to put that in set notation like this. So then just the number 5. So we have all the numbers, -infinity, all the way up to 3, not including 3. That's why there's a parenthesis. Union 5 as well is another output that can happen. What is the value of f of 0? It would be 5. That was easy. Okay, so let's look at this. We're almost done. We're almost done with this video with plenty of time. Oh my goodness. So this one pretty quickly, more quickly than I thought. f of negative 1. Let's start here. F of negative 1. We go to negative 1. We find the closed circle, which is right here, and we read this value. So that would be 1. I would suggest you pause the video at this point. See if you can answer these questions. F of negative 4. We go to negative 4. We go up to the graph. There it is. We read it off. It's 7. F of 2. We go over 2. We go up to right here. I don't know if you can see it. That's at 3. That's at 3. If I zoom in, maybe you can see it a little better. And then f of 6 is way the heck over here. The graph doesn't exist there. This doesn't have an arrow, folks. So it does not exist over there. So let's just put DNE. Does not exist. All right, what about these solve for x questions? These are always a little tricky until you get the hang of it, just like anything in life, right? When f of x equals 0, when f of x equals 0, when the output is 0, what are the x values? So this is the line f of x equals 0 or y equals 0. So you need to tell me these two spots right here. So it looks like x equals 1 or maybe about negative 2.3. I don't know exactly what it is. We could figure it out. I'm not going to worry about it. If f of x equals 7, I'm looking at the next one. Up here, this is y equals 7. There's only one spot that happens. It's at x equals negative 4. You see how I'm trying to show you where my eyeballs are going as I'm solving these. What about when f of x equals 6? Here's f of x equals 6. It looks like it hits twice, folks. That would be at 3. Or also, over here also, that's about negative 3.8, negative 3.8. All right, well, hopefully you found this video useful, and now you're all set, ready to go for graphing these. And I didn't mean to hit that. Sorry about that. I meant to hit this one, I think. Nope. I'm having some troubles here finishing out. There we go. There's the music, right? All right, so hopefully you're a pro at graphing piecewise functions, and you can just kill it on your quiz. All right, until next time.